I want you to picture the most frustrating moment in, I think, all of modern retail. You're at the self-checkout, you've scanned a whole cart of groceries, eggs, milk, that one weird vegetable you swore you'd actually cook this week. There's a line, maybe 3 people behind you, and you can feel them tapping their feet. You go to pay, you tap your card, and the screen just freezes.
Oh, the spinning wheel of death.
Exactly. It's not off, it's not on, it's just stuck in purgatory. And then the attendant has to come over, sigh really loudly, open some secret panel, and hard reboot the whole machine while you just stand there apologizing to everyone behind you.
It's a very distinct kind of modern misery. And usually, while you're standing there sweating, you're blaming the software, right?
Yeah, 100%.
You're thinking, who coded this garbage app?
I always assume it's a buggy update or just a bad UI.
Yeah.
But we have this stack of documents today that suggests I am, well, completely wrong.
Yeah.
We're doing a deep dive into a technology that claims the problem isn't the code on the screen. The problem is the literal electricity running through the wires.
It's the invisible layer. We call it the power substrate. And honestly, looking at the research for this, it's shocking how much we ignore it. We just assume power is, well, there, like air.
Well, today we're finding out that power is actually kind of dumb, and that stupidity is costing the global economy billions of dollars. We're looking at this fascinating set of engineering specs, strategy documents from a company called AI-Chip. And they're proposing something that sounds a little like science fiction, giving power a brain.
And we should probably mention these are not your typical dry white paper style documents.
No, that was the first thing that grabbed me. I opened the design notes and the visual direction is explicitly listed as metallic gold, neon green, and black. It feels like we're not reading about a circuit board. It's more like we're reading the manual for a piece of tech from, I don't know, Cyberpunk 2077.
It's definitely got that industrial sci-fi aesthetic, but the problem they're solving is very, very real. It's what the industry calls the vertical IoT crisis.
Okay, vertical IoT. Let's unpack that before we get into the neon lights. What are we actually talking about here?
Vertical just means industry specific. So we aren't talking about your laptop or your iPhone. We're talking about the point of sale terminal at the coffee shop, the medical cart in a hospital hallway, or, the industrial controller on a factory floor.
The invisible machines that actually run the world.
Precisely. And the crisis is that these machines are trapped in this economic gap. The documents call it the economics of deployment. Basically, these devices need to be as smart and reliable as a massive cloud server, but they have the budget of a pocket calculator.
Right. Because you can't just put a $2,000 NVIDIA GPU inside a frozen yogurt dispenser to keep it from crashing.
Exactly. That's the overkill option. It's too expensive, uses way too much power. So what happens is manufacturers go the other way. They use cheap, dumb power components, and that leads to the bane of every hardware engineer's existence, the no trouble found return.
No trouble found. Okay, this sounded like a detective story when I was reading it, so break this down for me.
Okay, so imagine that self-checkout kiosk freezes again. The store manager is angry. They ship the unit back to the manufacturer saying, this thing is broken. The manufacturer gets it, puts it on their test bench, plugs it in, and it works perfectly.
Because the test bench has clean, perfect power.
Right. But the store, maybe the store has an old HVA system. Maybe every time the air conditioning kicks on, the voltage at the wall dips for just 200 milliseconds. That dip of brownout, it confused the dumb power chip in the kiosk, causing the CPU to hang.
But the chip didn't record that. It didn't know what happened.
No memory, no brain. It just died. So the manufacturer sends the unit back saying no trouble found. The store plugs it back into the same bad outlet, and it crashes again a week later. It's this endless loop of wasted money and finger pointing.
And that is the gap AI-Chip is trying to fill. They want to put an AI brain right there in the power cable to stop that loop. They call it the AI-PMC.
The AI-embedded power management controller.
Now, I have to play devil's advocate here. Everything is AI right now. My toaster probably claims to have AI. Is this actual intelligence, or is this just a fancy surge protector with a big marketing budget?
That's a fair skepticism, but this is legit. And here's the key distinction. You have to understand the difference between a musician and a conductor.
I like that analogy. Break it down.
Traditional power chips, the ones in everything you own right now, they're the musicians, let's say tuba players. They just sit there. When they get a signal, they blow air, they convert 110 volts to 12 volts. They don't think, they just do.
They just follow instructions.
The AI-PMC is not a musician, it's the conductor. It doesn't actually do the heavy lifting of converting the voltage itself. It stands on the podium and it watches the musicians. It tells them how to play. It's a governor.
Governance. That word kept popping up in the specs. XR, governance. Extreme reliability.
Right. And it operates on 3 pillars: policy, evidence, and auditability. It enforces rules. So if the voltage starts to wobble, a dumb chip just lets it happen until the system crashes. The AI-PMC sees the wobble, it checks its policy, and it actively adjusts the system to compensate before the crash ever happens.
But where does the learning part come in? Because just following rules, that sounds like standard coding. The AI claim really rests on something the docs call drift detection.
This is the key to why this tech matters. Standard chips break suddenly. Smart chips can see themselves aging.
Okay, go deeper on that.
The spec mentions using a machine learning model called a one-class SVM. Most AI is trained to tell the difference between, say, A and B at versus a dog. This AI is trained on only one thing: normal. It learns the specific electrical heartbeat of that one single device.
So it knows that this specific cash register on a Tuesday usually draws this much current.
Exactly. Now imagine a capacitor inside that register is getting old. It's starting to dry out. It still works, but its performance shifts by maybe 1%. A dumb chip would just ignore it. The AI-PMC sees that 1% shift and flags it as drift.
So it's the difference between treating a heart attack and noticing high cholesterol 6 months early.
That is a perfect analogy. It turns reactive maintenance, fixing it after it breaks, into predictive maintenance. The device can basically send an email to the IT department saying, hey, I'm going to fail in about 2 weeks. You should send a technician now.
That saves the store from that whole frozen screen scenario entirely. But let's go back to that no trouble found mystery, the ghosts in the machine. The AI-PMC has a feature called the evidence spine that seems designed specifically to bust that ghost.
This is the black box flight recorder, and for me, this is the killer feature. When something goes wrong, a spike, a crash, a thermal event, the chip records an episode bundle.
Episode bundle. It sounds like a TV season drop.
Yeah, it's a lot less entertaining, but way more valuable. It's a high-resolution snapshot of the physics at that exact millisecond. Voltage, current, temperature. But it doesn't just dump a bunch of raw numbers. The Architectural Foundations document talks about a labeling rulebook.
Right, this is crucial. It categorizes the failure.
Yes. It labels the event. Was it an operational glitch? Was it a thermal overload? Or, and this is the key, was it an electrical sag from the wall?
And that settles the argument. If the log says input voltage sag, the manufacturer can prove it's the store's fault.
Exactly. It creates auditability. No more guessing. And here's where the AI loop closes. That data doesn't just sit there. It gets fed back into the system. The model learns.
The whole anti-fragile concept.
Right. If a kiosk in London crashes because of some weird specific type of power spike, the AI analyzes that signature, it updates the policy, and then conceptually, every other kiosk in the entire fleet gets an update. So now a kiosk in Tokyo knows how to handle that London spike.
The whole fleet gets smarter because one unit failed. That is a massive shift from how we usually think about hardware, which, just rots over time.
It's software-defined reliability. We're moving the intelligence out of the copper and into the code.
Okay, so that's the brain. But the sources also describe a body, a physical product called the XRVPP. And this is where that cyberpunk aesthetic actually, lands on a desk.
The VPP. vs. a power plate.
It's described as this anodized aluminum block that mounts to the back of a monitor. And the way they pitch this is interesting. It's not just a power supply, it's a counterweight.
Have you ever actually looked under the counter at a coffee shop?
Oh, it's a rat's nest.
Yeah.
It's all cables, power bricks, dust bunnies.
Exactly. The XRVPP is designed to kill that rat's nest. It bolts onto the back of the screen using the standard VS holes. It powers the screen, the PC, the printer, everything from one box. And because it's heavy aluminum, it keeps the screen from tipping over when you tap it.
It's smart design, but the feature that really caught my eye wasn't the mounting bracket. It was the ride-through, the RT500 flagship profile.
This is the hero feature. Ride-through is exactly what it sounds like. If the power cuts out, the device rides through the gap.
And the spec guarantees 500 milliseconds, half a second. To a layperson, that sounds like nothing. Why is half a second such a big deal?
In the world of electricity, half a second is an eternity. Most power glitches, the kind that make your lights flicker during a storm, are maybe 100 to 200 milliseconds long.
But that's enough to kill a computer.
Oh, absolutely. A 50 millisecond drop will reboot a standard PC. And a reboot takes, what, 5 minutes?
5 minutes of very awkward silence while the customer just stares at you.
Exactly. With the XR-VPP, the wall power can cut out for a full half second, and the machine doesn't even blink. The screen stays on, the transaction finishes. The customer walks away with their coffee, completely unaware that the building just had a brownout.
But what if the power goes out for longer? Like, say, 10 seconds? This is where the AI gets ruthless. The documents talk about intelligent shedding.
This is my favorite part of the logic. A dumb battery backup tries to save everyone. It tries to keep the screen bright, the printer on, the accessories charging, and because it tries to save everyone, it drains the battery in seconds, and then everything dies.
The AI-PMC plays favorites.
It creates a hierarchy of survival. It looks at the policy. It says, okay, power is gone. Priority 1, keep the CPU alive. Priority 2, keep the receipt printer online. Priority 3 is the USB-C port charging the employee's vape pen.
Goodbye, vape pen.
Instantly. It cuts power to the peripherals. Then it dims the screen backlight by 50%. It throttles the processor speed. It sheds the cargo to keep the ship afloat.
It's like that scene in Apollo 13 where they have to turn off the radar and the heater just to have enough juice to make it back to Earth.
It is exactly that. It extends the runtime by sacrificing the non-essentials. A dumb power supply can't do that because it doesn't know what a printer is, it just sees a load. The AI-PMC understands the context of a device.
I want to pivot a bit to the people behind this, because usually when we see specs this detailed and an aesthetic this specific, we're looking at some massive tech giant. But AI chip seems to be operating differently.
They are. They have a very specific triad leadership team mentioned in the bios, and their strategy is, well, it's conservative in a really smart way.
They call it the FPGA to ASIC path. For those of us who didn't major in electrical engineering, can you translate that?
So if you want to make a computer chip, an ASIC, you have to design it and then pay a foundry millions of dollars to make the physical molds. And if you made a mistake, you just set $5 million on fire.
That's high risk.
Insanely high risk. So AI chip doesn't do that, not yet. They start with an FPGA, a field programmable gate array. Think of it like a blank canvas chip. You can write the code, test it, and if it's wrong, you just erase it and rewrite it.
But FPGAs are more expensive per unit.
They are. But they allow you to prove the governance logic works in the real world without all that upfront risk.
So they get the episode bundles, they see the drift in real scenarios, they refine the code.
And only when the logic is bulletproof, when it is execution grade, only then do they commit to the expensive, hard-coded chip. This is the influence of Ying-Pei Chen, their head of silicon. He's minimizing that exotic risk.
And then you have Dennis Liu, the strategist. His bio is all about supply chain governance.
Right. He's the reality check. He knows that the company making the checkout kiosk isn't going to pay a premium unless the ROI is just totally obvious. He's the one saying, this can't just be cool, it has to save money on returns.
And Jim Sheen, the operator.
The scale guy. He's the one who ensures that when they do move to mass production, they can build 1 million of these things without defects. It's a very balanced team. Innovation, market reality, and manufacturing scale.
I noticed in the engineering spec document, the tone is incredibly rigid. They talk about pinning every single version of their software. Python 3.11, specific compiler versions.
No cowboy coding.
Exactly. Why is that so important here?
Because if Instagram crashes, you get annoyed and you just reopen the app. If a power controller crashes, you can fry the motherboard. Or, in a medical setting, a ventilator stops working.
The stakes are different.
The philosophy is execution grade. They are treating this code like it's going into a satellite or a pacemaker. You don't update a pacemaker over the air on a Tuesday just to try out some cool new feature. You need absolute stability.
Which explains why they aren't trying to cram a chatbot into the power supply. They explicitly mention using simple, reliable compute, like standard microcontrollers.
That's the domain-native approach. They use AI only for the things AI is uniquely good at. Pattern recognition for drift, complex decision-making for shedding. They aren't trying to ride the generative AI hype train. They're staying in their lane, and their lane is reliability.
So let's zoom out here. We started this whole conversation with a frozen checkout screen, but we've ended up talking about a fundamental shift in how hardware is built.
It's a shift from big iron to smart silicon. Historically, if you wanted reliable power, you bought big, heavy, expensive components. You over-engineered the physical world.
Thicker cables?
Bigger capacitors.
Right. AI chip is saying, we can use standard, affordable hardware, but we will wrap it in such intelligent software governance that it behaves like high-end hardware.
It's democratizing reliability.
It is. It means that the cheap checkout kiosk can be just as robust as the expensive mainframe, because the power substrate is doing the thinking for it.
And for us, the consumers, it just means we stop staring at blank screens.
Ideally, yes. The best technology is the kind you never even notice. You don't see the AI-PMC adjusting the voltage or shedding the USB port. You just tap your card, it beeps, and you leave.
I want to leave our listeners with a final thought that really stuck with me. We talked about the evidence spine, the logging of exactly why something failed. Imagine if we had that in our own homes. Oh, that would be a complete game changer.
Your toaster stops working. Today, you throw it in the trash because you have no idea why it broke. But imagine if you got a notification on your phone. Heating element B has drifted 20% outside of policy.
You know exactly what's wrong.
You could fix it. Or at the very least, you'd know it wasn't your fault.
Think about the e-waste implications. We throw away millions of tons of electronics because of no trouble found or minor component failures we just can't diagnose. If the wall socket acted as a diagnostic tool.
Trouble found, and here is the receipt.
Exactly. It forces manufacturers to be honest. If the data says their capacitors are failing after 6 months, they can't hide from that.
It feels like the humble power outlet is about to become the smartest thing in the room. And honestly, if it saves me from waiting 10 minutes for a reboot, I am ready for the cyberpunk future.
I am right there with you.
Thanks for plugging in with us today. It's a layer of the world we rarely see, but it keeps the lights on.
Thanks for having me.
Check your drifts, watch your voltage, and we'll see you in the next deep dive.